Okay, so number 21, we're looking at finding the sum or the difference. So on problem 21, again, I'm not going to write the problem down. You guys already have that. So what we would do there, in this one, they already have common denominators. We would always need to find a common denominator if you're trying to add or subtract fractions. But for the first few, you have common denominators already. So right on this one, 5x plus 8 is the common denominator. So we're looking at, this would be what we write next here. So the denominator is going to have 5x plus 8. That is the common denominator. We need to basically add 6 plus 22 up on top here. That's our numerator numbers. That's just going to give us 28. And that's all it is. That was a simple one. So these first couple will go pretty quickly. 23. For this one also has a common denominator, x minus 13. So that'll be our denominator, the common one. And so then we got 6x minus 78. So we're just going to put that on top. Since they're not like terms, we can't combine them like we did over here. We're just going to make a binomial out of them, 6x minus 78. But now here's the one thing is that I notice I could factor out something here from the top because I know definitely 2 goes into 6 and 2 goes into 78. But let's see if there's anything bigger. In fact, let's see if 6 goes into 78. So I say 78 divided by 6, could that go in evenly? And it does, 13 times. Notice that's a 13 like we have at the bottom. So this would probably be able to be simplified. If we can factor out the 6 now here, that would give us an x here minus 13 binomial. And we have that same binomial at the bottom. Matching binomials we can always cancel out. And so we're going to be canceling out these matching binomials. That leaves us just with a 6 as an answer. So 6 is our answer. But we probably do need to say that x can't be 13. That's what we're probably going to have to say, comma here, x can't be 13 as an excluded value since we did cross out x minus 13. So it is 6 for an answer, but with the x cannot equal 13. Number 25. So this one we need to find a common denominator. So we got 8x squared. We want to make sure everything's in factored form. So let's make sure we have it in factored form. I'm going to just write this first one again because that's just a monomial at the bottom. And then it's a minus. And then the second fraction's got the x on the top. And we want to factor now that bottom of the second one, 4x squared plus 12x. We can factor a 4x out of that. So we want to factor 4x out, and what would be left would be an x minus, or not minus, plus, say plus there, 3. Because 12 divided by 4 would be 3. And the x is already out of that. So if I were to distribute this 4x back into here, I'm going to get exactly what I have with that 4x squared plus 12x. So now I'm looking for kind of an LCD with these two denominators. So we have monomials. This is a monomial, the 4x is a monomial. So we want to count most. So we want to think, okay, whoops, get that out of my way. LCD, what's the LCD here? So as far as like most for 4 and 8, well 4 can go into 8, so we're definitely going to have 8 as an LCD for this monomial. This has x squared, this has x, so we need the bigger one, x squared. So as far as monomial, we need 8x squared in the LCD. We also need this binomial over here because this one doesn't have it. We need to include x plus 3. So that whole thing is the common denominator. That means we need to then use that now to make equal fractions here. So for this one, it already has the monomial 8x squared, but it doesn't have the binomial. So I'm going to need to multiply this 5 times the x plus 3 binomial in that one. And for this one here, it has the binomial, it has a 4x, but what it needs is basically it needs 2 to make that an 8 and another x, so 2x. So I need to multiply this x by a 2x. Okay, so now we'll just be working on the numerators here. 5 goes into this with a distributive property, so that's going to just be, so I'll put my first fraction here. That's going to be 5 x plus 15 And then I'm going to keep this all in one big fraction here because I'm going to put this down next. So this is a negative x. You may want to make that a plus and make this a minus x there so you don't forget that sign. Negative x times 2x is negative 2x squared. So negative 2x squared. And it's all over the common denominator, the LCD, which is the 8x squared and that x plus 3 binomial. Okay, so what we have up on top here would be a quadratic, and the only thing we could maybe do at this point is see if it's factorable. If it is factorable, then we could get it to 2 binomials, but it doesn't look like it is. So this answer, let me see, I think it's probably going to put it in descending order though. This is what, 25. I think they want this in descending order. Probably that negative number is going first, 2x squared. Yeah, that's all they want there. So in the answer, I mean, that's fine. This is the answer basically. They just rearranged these terms up here to put the numerator in descending order. So here's how the answer would look on your paper, or as your multiple choice. It would be putting this negative 2x squared first, then the plus 5x, then the plus 15, and it's all over that common denominator. So that's what the answer looks like, just in the right order for the numerator. And that's it. Because this was not factorable up on the top, so there's nothing we can do with it. Then we go to 27. So number 27, we need a common denominator here as well. There's nothing to factor for this one, so we just want to figure out, okay, what's the LCD? So our LCD for this one, we see we got a binomial, 2x plus 7. We also have a number 6, so we got to include both. Basically, we're going to multiply just these times each other. So 6 times this binomial of 2x plus 7. That's the LCD. So actually, I probably should write these fractions down. I think that'd be helpful. So let me do it. I'll do it like this. So let's see. X is over 2x plus 7 here. You don't need to write them down because you already have them down, but it'd be helpful if I have them down, I think. So that's what we see here. Now we need to figure out, okay, what do we need to multiply each numerator by? This one already has the 2x plus 7, so we just need to multiply this one by the 6. So we're going to times this one by 6 here, x times 6. This one has the 6, it needs to be multiplied by the 2x plus 7. And so now we can see we're going to do all this on the top here. So 6 times x would be 6x to start with. This is a negative 1, so you may want to make this a plus and make the 1 negative, so you can distribute negative 1 into this. That's just going to change these signs to negative 2x minus 7, and it's over the LCD of 6 times the 2x plus 7. And we just couldn't combine some like terms here. We're going to see that's going to be 4x then. So we're going to combine 6x minus 2x to get 4x, then minus 7 is over our common denominator 6, and then the 2x plus 7. And that's as far as we can go. We can't simplify this. There's no way to factor the top. There's nothing to cross out or cancel to reduce this, so that is going to be just our answer right there. Just like that. Let's see, next one, 20, so that was 27. That took us out of, that's all the sum and difference stuff. Now going into the solving equations now. 29 is a cross-multiplying problem. I should probably write the problems down though, just on this one so you can see it. I think that'd be helpful. Is equal to 6. You already have the problem written down, so okay, so we want to cross multiply. When we have a fraction equal to a fraction, we're going to cross multiply, and so it's going to give us like 2 times this one, 2 times 6x plus 6. So we got now 6 times the other one the other way, so equals 6 times this binomial. So distributive property on both of these, we're going to see that's going to be a 12x plus 12. And then this one's going to be 6x plus 42. And that's just now, we can be very easy to solve this now. Let's subtract the 6x from both sides. Those cancel, and we got 6x plus 12. There's x there, plus 12 is equal to the 42. And then subtract a 12. And so that's going to cancel those. Over here we're going to say it's going to be 30, so 6x is equal to 30. And so it means that x is equal to 5. So there we go, x is equal to 5. And that's it. That's all there is. Let's see. I'm going to go to the next screen. So 31 is our next one. Again, it's a fraction equal to a fraction, so another solve it by cross multiplying. Actually, I think I can do it over here. I'll do it on this side. 31, I'll put right here. So our two fractions, we got x over 2, x plus 9. I'll write it down so we can see it. Is equal to x plus 2, or x minus 2 over x plus 2. X plus 2. So when we cross multiply, we're going to see x times this x plus 2. So x times x plus 2. And it's equal to these two binomials times each other. So we're going to see x minus 2, I'll put that in a parenthesis, times the other binomial, 2x plus 9. So that's what you want to write down. And we're cross multiplying, and you cross multiply whenever you have a fraction equal to a fraction. So distributive property on this side is going to be an x squared. It's going to be 2x. On this side we're going to see x times 2x. We're going to have to FOIL this. So we have 2x squared. And then outside is 9x, and the inside will be negative 4x. If you want to write that all down separately, you can. You could say, well, it's outside's 9x, inside's negative 4x, and then combine it later if you want to in the next step. And then the last one's negative 2 times 9 is negative 18. Because we're going to have to put some stuff together here anyways. We have a quadratic equation, basically. We're going to need to bring everything over to this side where there's more x squareds. This one has 1x squared, this one has 2x squareds. We want to keep the x squareds positive, so let's subtract x squared from both sides. We're also going to subtract 2x from both sides. I'm going to subtract it from these x terms over here. So all of that's going to be done. So we can cancel the x squareds here and the 2x's. That leaves us with 0 now on this side, equal to 1x squared. And then all our x's got to combine. So let's, if I take 9 minus 4 would be 5, and 5 minus 2 is 3. So that means a positive 3x is there, minus the 18 then. And then let's try to see if this is factorable with the simple method. It probably is. So we'll see 0 is equal to 2 binomials. And so we'll start with putting the x's in the front. The two numbers would be probably 6 and 3, because they subtract to give us 3. So 6 and a 3. They got to be different signs. The 6 is the bigger one. It's going to be the sign of this middle term plus. So it's going to be plus for 6, minus for 3. And so now we can kind of just make two equations out of this. X plus 6 will equal 0, x minus 3. So we're getting two answers here. So we're going to see, okay, x plus 6 is equal to 0. When I subtract, that's going to be x is equal to negative 6. And then I'll see x minus 3 is equal to 0. When I add 3, x is equal to positive 3. The only thing we need to check for is either one of these answers an excluded value. If we look back up in our problem here, it is not. The excluded value would be a negative 2 and some fraction over here like negative 9 over 2. So we're good with keeping both of these answers. Those are the two answers. We get two answers on that one, and we can keep them. Alright, let's move on to the next one. Now the next one is not cross multiplying. It's going to be using the LCD, multiplying everything by the LCD to get rid of the fractions. And that's what we're trying to do. We're trying to undo the fraction part so we can solve this. So we're on 33 here. And I'm going to have to write this whole thing out. So 1 minus 4 over x minus 3 equals that 3 over x. So we need to know what is that LCD from our problem here. It's just these two are the denominators. There's nothing in common with them, so we're just going to put them next to each other. So x times x minus 3 would be the LCD. That's what we need to multiply this entire thing by here. I'm going to put the whole thing in parentheses and multiply by this. So this first one, 1 times this whole thing, is just going to be that. So I'm going to say, okay, this is going to be down here for the first one. 1 times the LCD is going to be just the LCD. So this is what we get here for that first part. This next one here, we're going to see we can cross out the x minus 3, but we still have the x to multiply our 4 up here. We might want to do this change that to plus and make this a negative 4 to realize that is a negative 4x then. So this will be a negative 4x right there. Then we'll put our equal sign down. This one we can cross out the x with this x here in the LCD, but there's still the x minus 3 here to multiply this 3, so this is going to get multiplied by that x minus 3. So we can say it's 3 times x minus 3 on the other side of that equal sign. So that's how we get rid of the fractions, and now it's just an equation we can go ahead and solve with first distributive property, x times x here, x squared, and then negative 3x. Negative 4x is next to it. Over here we're going to get 3x and a negative 9. So we do have a quadratic when we see the x squared. We want to take these two terms on this side, bring them over to the other side. So I want to subtract 3x. I'm going to subtract it from the x terms I see all in here. I want to add 9, so I'm going to add 9 to the back of this whole thing. So I'm going to cancel these out over here. Those cancel out. Now I can say equals 0. On this side we have the x squared. Let's see, we got all negatives. We're just going to add these up. So this would be a negative 10x. So this makes negative 6, and then negative 4 more is negative 10x, and then plus the 9. And we want to see, can we factor this? And I believe we can. So it is probably factorable. We start off just with the x squared, that simple method. 9 times 1, and they add to give us 10. So that's the numbers, 9 and 1. They're both the same, they're both minus. And so it's going to say x minus 9 equals 0, and an x minus 1 is equal to 0. Oops, equals, I'll get rid of that, equals 0. So this one we're just going to add 9, so x is equal to 9. This one we're going to add the 1. So we just again want to check, are either one of these the excluded values from the problem? The excluded values would be 0 and 3, so we're okay to keep both of these answers then. You only don't keep the answer if one of your answers is an excluded value, and it's not. So both 9 and 1 are fine to keep. All right, 35. Okay, I need to write this out again. So I'm going to see 10 on top of x minus 2 is equal to 16x squared is over x squared minus 4. And actually I want to see that as two binomials. This x squared minus 4 really is x minus 2 and x plus 2. So we do want to see that as we start to figure out what the LCD is. So I'm going to write it down as the two binomials instead of the difference of squares. Minus the 8x. So you may want to write, just right underneath this x squared minus 4, write those two binomials so you know that's what those are. That would factor to the x minus 2, x plus 2. So what is our LCD on this one? It's just those two binomials. It is what these two are, because this one has the x minus 2, this one has an x plus 2, this one has both. So the LCD would be both x minus 2 and x plus 2. We're going to need to multiply this entire fraction by that LCD. Parenthesis didn't go all the way down. We cannot just cross multiply because we have three fractions. We have two fractions on one side. It's not a fraction equal to a fraction situation. So that's why we just can't cross multiply. So for this one, it has the x minus 2, so we can cancel that one out, but it needs to still be multiplied by x plus 2. So this 10 here is going to get multiplied by x plus 2, so we're going to see it's going to say 10 times x plus 2, and then equals. This one has both, so both can cross out, which means there's nothing left to multiply this 16x squared. We're just going to see 16x squared come down in our answer, or our equation. And for this one, it has the x plus 2, which we'll cancel that x plus 2 out, but we need to multiply this 8x by the x minus 2. And so we need to realize that this is going to be a minus 8x. If you want to change that to a plus and make it negative, either way you need to see it's going to be a negative or minus 8x times the x minus 2. Make sure you get that sign correct so you don't distribute the negative 8x then. Okay, so all our fractions are gone. We just need to now get rid of the parentheses with the distributive properties. So 10x plus 20 on this side. 16x squared, and then this is going to multiply in. It's going to be a negative 8x squared there, and then it's going to be a positive 16. So it looks like we're going to have another quadratic. We're going to, get like an 8x squared on this side. We want to bring both of these terms then to the right side. We're going to subtract 10x. We're going to subtract 20. So we'll subtract the 10x from over here. There's nothing to combine with the 10x, but when we subtract 20, we'll subtract it from this 16 here. So these cancel out here, leaving us with 0 on this side. 16 minus 8 is 8x squared. And then we have a negative 10x. And then these two, it's going to combine here to give us a negative, let's see, take 16 away, that's negative 4. So what I do notice is that the numbers 8, 10, and 4 are all even. I can reduce my trinomial here at least by 2. So if I divide everything here by 2, I can do that. Even the 0, if I divide 0 by 2, it's still 0. So I don't have to really worry about that. But we can divide all that by 2. So we get 0 now equals 4x squared minus 5x minus 2. This makes our numbers a little easier. So could we factor this one? We would need to factor it with the star if it was factorable, which means I could try it. I could do the star method over here. The 4 times negative 2 would be negative 8. That would be the top. Negative 5 would be the bottom. And I would need to figure out, is there two numbers that multiply to give me 8 that would subtract to give me 5? Well, let's see. 4 and 2 won't work. 8 and 1, that won't work either. That's all I really have as options. So it is not factorable. That doesn't work. So that leaves us with having to use, I would say just use the quadratic formula. So that would be, let's write it down again, x equals opposite of b plus or minus square root of b squared minus 4ac all over 2a. Okay. So let's go ahead and plug these in here. So now we're going to say opposite of b. So we're going to say, okay, our x is equal to, so we have our a is 4, b is negative 5, and c is negative 2. So opposite of negative 5 is 5. So 5 plus or minus square root of negative 5 squared minus 4 times a, which is 4, and c, which is negative 2. And it is all over 2 times a, which is 2 times 4. So let's start to simplify this. We're still going to have that 5 on the outside. And 25 now here with negative 5 times negative 5. See, it's going to be a positive because I have two negatives. And so basically we're going to see 16 times 2, that's 32. So it's 25 plus that right there, all over 8. So a 25 plus 32, this is a 32 there. We'll keep simplifying. So 5 plus or minus the square root. Let's see, that's going to be, what, 57, looks like. 57 all over 8. Alright, let's go back here and fix my mistake. So let's go here. So this distributive probably right there messed up. 16 should have had an x. So that should have combined with this x here and not the 20. So this whole thing is basically all of that is a mess. So I'm sorry if you wrote all this down and it's not as easy for you to erase, but you don't have to erase it if you just want to cross it out and then just write the right stuff. That's fine. It's just for you really to understand. But I mean, it's good sometimes for you to see me make a mistake because I realize that I have to make mistakes sometimes and figure out my mistake and fix it. You have to get rid of this too. All of that's going to be different. This was okay so far, so that was okay. So I was okay with getting these two over here, yes. So this was a 0, yes, here. 16 and 8, that was still an 8x squared, I believe, there. But now we got to say, okay, take 10 away from 16x. That should have been plus 6x. And then minus 20. And now I can divide everything here by 2 to make this smaller. So dividing by 2 would give me 4x squared. This is going to be a 3x. And then 10. All right, so now let's see if this would work with the star. So that's going to be negative 40, and this is a positive 3. So will the star work this time? Two numbers that multiply to give us 40, like 8 and 5, they do subtract to give us 3. So this was able to be used with the star method. So I want to say, okay, it's going to start with 4x. We're going to put the 4x on top of each side here. And so we're going to use that 8 and 3. So 8 and 3 are the two numbers. They multiply to give us 40. They also subtract to give us 3. So 8 and a 3. The signs, they should be different signs. The bigger one's going to be positive. So 8's going to be positive. That's going to be a negative right there. And so then we see, oops, not 3, 5. See, I'm making a mistake again, aren't I? That's too big. Meant 5 right there. I don't know why. I think I saw 3 there and I put 3. So this should be 8 times 5 is 40, and you subtract and get 3. There we go. Okay, so on this side, we can simplify this a little bit. We can simplify by 4, really. So this actually is just going to be an x, and this one's going to be a 2. So plus 2 right there. So one of our binomials we can say here is the x plus 2 binomial. And the other one's going to come from this, of 4x minus 5. So now if I FOIL this, I would get this trinomial. And as I do this, here we're going to set each one equal to 0 separately. So 4x minus 5 equals 0. This one we subtract 2, x is equal to negative 2. This one we add 5, so 4x is equal to 5, but then we have to divide by 4, so x equals 5 divided by 4. So that's 5/4. So those are our two answers. Can we keep both? Can I keep my negative 2? What's my excluded values up here, which is the LCD basically? Positive 2, negative 2 are the excluded values. So I can't keep negative 2, right? Because it's an excluded value. So we got to get rid of that one. That one's can't keep. This is the only one I can keep for an answer. So 5/4 is the only answer on this one. So multiple choice, I'm sure they would probably include both of those on one of the multiple choices to try to, trick you or see, do you understand excluded values to know that you can't keep that one. This would be an extraneous solution here. All right, 37 is our last one to do. And that one's a little different. It's going to be a find the inverse problem. So 37, find the inverse. Let's write down the function here. Or for me to write the function down, you already have it. X minus 5 is over 3. Okay, so it says determine whether the inverse is a function, then find the inverse. I want to find the inverse first, I think. And then we can determine whether it's a function. So we want to find the inverse of this thing first, which we need to realize that the f of x, again, is our y. So that is our y right there. And again, this is where we switch and solve. We're going to switch x and y, and then we solve. Oops. Solve for y. Switch and solve. So if we're switching, we're going to say x is equal to y minus 5 over 3. And to get this to solve for y, we want to first multiply by 3. So we're going to times this by 3. So 3 is canceled. Times this also by 3 over here. So 3x is equal to y minus 5. And now we're going to be able to just say add 5. So plus 5. So our y then would equal 3x plus 5. So this is our inverse function. If we want to write it back with the f of x, we could say it like this. F of a negative 1 of x, that's showing that little inverse. The negative 1 shows the inverse notation. 3x plus 5. So this is the inverse of the function. So it says determine whether the inverse is a function. Well, this is a linear function. That's like mx plus b, and all linear functions are functions. All the mx plus b's are functions, so we would say definitely, yes, it's a function. So we didn't really have to really check anything. A lot of times you can use a vertical line test to see if it's a function. Just go across with a vertical line on the graph. You could graph this with like the Desmos calculator or something, or realize what the graph is and then go across it. All right, was there any questions that you might have had at that point for me for... Okay, so at this point you should now make sure you do the even numbers on your study guide, and I'm going to show you the answers to the even numbers, but do the even numbers first, then come back and watch the rest of this video for the answers to those even numbers. Okay, so you should have watched the answers or done the even numbers, and now here are the answers to those even numbers as we start to go through that. So here we go, number 2. So our answer here is this graph. Graph should look something like this. Branches are in 2 and 4. Your asymptotes are the x-axis and the y-axis, and it does get, it says further from the axes on this one. That's because it is a negative 15 on the top. Number 4. Here's number 4. You can see the branches here would be in 1 and 3. The situation, says the domain is all the real numbers except 3. The range is all the real numbers except 6. So that would mean our asymptotes would be at 3 and 6. X equals 3 right here, and y equals 6. That's where the asymptotes would be. And you can see it's going to be on this one 3. It's going to be a little further away than the 1 would normally be. Number 6. Here it is. So for 6, it would be in this situation 1 and 3 as well on this one. Domains, the all real numbers except 3. Range is all real numbers except 4. So your x equals 3 line this way and y equals 4 line this way. Those would be the asymptotes on this one. For number 8, let's come down to 8. There we go. There's our answer for 8. X minus 2 over x minus 4, where x cannot equal negative 4. At number 10, our answer there would be 5 over x plus 7, where x cannot equal negative 6. Then we got number 12, which would be, the answer there is 2x to the, well, those are pretty small exponents there. Let me see if I can get this better. That doesn't really look that much better either. Let's see. Just awful blurry. This is what number 12. Let's see if I can think about what this would be. Let's see, 12. We got x is going to be 11 on the top, but then 5 on the bottom. So that's going to be 6. So that's a 6 there. So 2x to the 6th. The y on the bottom should be there's 5 and 2 is 7. That means there's 2 on the bottom. So it's a y to the 2nd power on the bottom. So 2x to the 6th over y to the 2nd, and x cannot equal 0. And then number 14. 14, we see 5 times x minus 1 over 14x, and x cannot equal negative 3, and x cannot equal 6. Number 16 would just be x plus 5 over x minus 4, and that would be it. Number 18, this one, it's the two binomials on top, x minus 3, x minus 10, and then x plus 10, x plus 3 on the bottom. And x can't be these three numbers, negative 4, negative 2, and positive 10. Number 20. Number 20, it's 1 over x plus 5, and x can't be negative 9 or 6. 22 down here, so 22 is 29 on the top, 15x squared minus 13 there at the bottom. That would be that common denominator. 24 is just 7, but x can't equal negative can't equal 9. So the answer is just 7, but x can't equal 9. And let's see, 26. We're going to see negative trinomial on top, negative 4x squared plus 3x plus 9, and on the bottom there's your common denominator, 16x squared with a x plus 3 binomial. 28 is 2x minus 9 for the numerator, 4 times 2x plus 9 as the denominator. Let's see, that was number 30. X equals negative 64 is our answer for that one. As we get it down into the solving equations. Number 32, x equals negative 9 and x equals 7. Those are the two answers that we can keep on that one. 34 would be x equals 8, x equals -1 for 34. And 36, just one answer, x equals 2, so you're probably going to end up having to have an excluded value as an answer, and so that would be an extraneous solution. So one of those are probably extraneous. You probably got 2, but really you can only keep 1. And then our last one, number 38, would be g of x. You can say g of x or f to the -1 of x, but basically this is the main part over here. 4 over x plus 11 is the inverse function, and it doesn't say anything about whether it's a, oh yeah, there it is, yes. So yes, it is a function, just like it did up here on 37 that we did in class. Yes, that was a function. Yes, this is a function as well. So okay, that was it. So that's the answers. Keep studying for the midterm, which is going to be at the end of this week. So I'll see you back when that happens.